Okay, welcome back. Now we're going to talk a little bit about some of the downfalls of floating point. Hopefully you've already noticed a couple of these with the bits falling off as well as the floating point precision. So one thing to keep in mind is that the order that you do adds will actually produce different results. For example, let's go ahead and let's look at, we have our different values of x here. So notice that x and y are basically the opposites of one another, so if you added the two they'd become 0, and then we're going to have z, which is just 1. But notice that x and y have a very large exponent. Okay, so there's two different ways to do the addition. One is if you do, let's do x plus y plus z, we want to add all three. Well, what happens if we add the x and the y first? Well, first off we get 0, great, and then we add 1, and so the answer is 1. And that's actually the correct answer mathematically speaking. On the other hand, what if we decide to add y and z first? Well, 1 plus this large number, the 1 can't be captured in the mantissa or the fraction because it's too large. So that 1 is literally just dropped off and ignored. And then if we add the x to that result in the end, we get 0. So, very important. The order that you do these additions will change the actual answer, and this is the accepted behavior for floating point precision. So keep in mind that you are always losing precision and that the number is not absolutely correct, which can be very detrimental in certain situations, like for example your bank account. Speaking of your bank account, there was a situation actually when the Intel Pentium first came out that they did not implement the floating point hardware correctly, and so what happened is when they were using floating point at the time to do these additions, people were losing pennies or 0.002 cents. And of course, hopefully you can see that if you did this a lot, like in Superman 3, you could eventually accumulate to a very large sum of money, or losing a large sum of money, or basically just money disappearing. So Intel actually had to go in and fix this. They were not able to give a software update because this is all on hardware, so you have to actually ship out new processors. So doing this type of bug, or even bug in floating point, can be very detrimental. So real quickly, one thing they want to talk about is bits have no inherent meaning. They're just numbers, ones and zeros, until we actually sit down and figure out what we want those bits to represent. Then we can have them represent something like, for example, this slideshow. Computers represent numbers finite in range and precision. So not only the range is easy because you notice that single floating went from -38 or 10 raised to -38 to positive 38, and double was something similar. But there's also a precision issue where you can only have so many bits of precision, like we showed earlier, where that 1 disappeared when we were doing addition. So there's different floating point pitfalls or issues when you use floating point. Now, a lot of y'all might see after this that maybe we should never use floating point, and in some degree that is correct. But for a lot of simulations where you're having bodies of objects out in some type of plane, it's very advantageous to at least come up with a simulator to give you an approximate answer to certain questions. And when you have floating point hardware to support that, it can become very fast. And so these numbers are still very useful for scientific research. So yes, different ISAs support these differently. Keep in mind that while we have a ton of instructions, looks like for MIPS only 55 are the most frequently used instructions, account for 100% of our SPEC-C benchmark, INT benchmark, and 97% of the floating point benchmarks. All instructions are used less frequently. In other words, even though we are only implementing 8 instructions inside of our processor, in general that will cover a large or a very significant portion of the instructions needed. Obviously there's going to be more, but we don't need to get to that, at least in this course. And that's all for now. Let's go ahead and look at Scrum Do.